Here's the strange part about the AI boom. A company can spend $1 million on one AI rack, ship it into a data center, install the chips, and still make nothing. Not because demand is weak, not because the hardware is useless. The customers may already be waiting. The contracts may already be signed. The rack may be sitting right there, lights on, fans spinning, inside the building. But it cannot run. The room was built for yesterday's servers, and yesterday's servers did not throw off heat like this. So the machine sits there, offline, expensive, almost ready, but not ready enough to sell. Until engineers can move the heat away, the compute cannot be delivered. And every day that rack stays offline, the money keeps burning. That is the less glamorous side of AI. NVIDIA may design the chips. Cloud companies may spend billions buying them. Investors may talk about models, tokens, and training runs. But owning the hardware is not the same as owning usable compute. The machines have to run safely. They have to run continuously. They have to run when customers are actually paying for them. Every AI server takes electricity, turns it into calculations, and sends most of that energy back into the room as heat. And as more power gets packed into each rack, cooling stops being a background building cost. It becomes part of the product. So the question is no longer just, who can buy the newest chips? The real question is, who can turn those chips into reliable compute that customers can actually use? That is why keeping AI cold is becoming a billion-dollar business of its own. Now, GPUs get all the attention. They have brand names, model numbers, price tags, benchmarks. People talk about H100s, B200s, clusters, and training capacity. But let's be honest, cloud providers are not buying processors because they want something beautiful to display inside a machine room. They are buying the hours those processors can spend training models, answering customer requests, and running software. What they are really buying is uptime. A data center makes money when its equipment is available. If customers need compute, but the machines cannot run, then it does not matter how advanced those machines are. A silent rack does not sell tokens. It does not train models. It does not answer API calls. It just sits there. Once the hardware enters the building, power, cooling, and maintenance are no longer background details. They become part of the service being sold. And this is where AI starts to look less like software and more like manufacturing. Think about a factory. A factory can own the best machines in the world, but if those machines are waiting for installation or stopping every few hours, they do not produce revenue. An AI data center works the same way. Its product is compute, but that product depends on everything around the chip: the electrical system, the cooling system, the maintenance team, the building itself. And one of the biggest changes is density. Older data halls were designed for much lower power per rack, but new AI systems can demand several times more power in the same amount of floor space. At that point, cooling is not ordinary air conditioning anymore. It has to be designed together with the rack, the power system, and the building. For years, data centers mostly relied on air. Cold air moved through the room, it passed across the servers, then it carried heat away. And for many machines, that still works. But high-density AI systems are pushing air closer to its limit. Air can remove heat. Of course it can. But when huge amounts of power are packed into a small space, air starts to struggle. A room built for conventional servers may look fine on paper. Then a row of AI racks arrives, and suddenly, the old plan does not hold. Too much heat, too little room for error. That is why operators are moving cooling closer to the chips. Instead of asking room air to do all the work, liquid can move through cold plates, pipes, and heat exchangers. It takes heat away directly from the source. Now, the engineering can sound complicated, but the business result is very simple. New AI racks may need new pipework, new cooling distribution units, larger chillers, new maintenance procedures. And sometimes, the expensive hardware is already inside the building, while the facility still needs months of work before it can run at full capacity. That delay creates a whole new market. Cooling equipment companies, mechanical engineers, pipe installers, heat management specialists, maintenance providers. These companies are not selling artificial intelligence. They are selling something more basic. They are making sure the expensive machines stay online long enough to sell it. And as AI racks get hotter and denser, that service becomes more valuable. But the cost does not stay inside the data center. That is the part people often miss. AI feels like a digital product. A model answers a question, a chatbot writes a paragraph, a system generates an image. It feels weightless. But behind that answer is real land, real electricity, real cooling equipment, and real construction. A new AI project may need a bigger grid connection, more transformers, additional cooling equipment, major building work. Depending on the location, it may also face questions about water, planning approval, equipment delivery, and local infrastructure. Now, this does not mean data centers should not be built. It means AI is not a weightless product floating inside some invisible cloud. Someone has to finance the building before it earns revenue. Someone has to install the electrical connection. Someone has to build the cooling plant. And someone has to keep the facility running through equipment failures, summer heat, and sudden spikes in demand. Those costs do not vanish. They move through the business chain. They affect the price of cloud capacity. They affect corporate AI budgets. They affect the cost of delivering software services. The user sees a chatbot answer in seconds. But behind that answer is an industrial facility running around the clock. It consumes power. It removes heat. It keeps machines alive hour after hour. AI may feel digital to the customer, but the cost of running it is physical. Now, in the previous video, we followed the AI chip supply chain. NVIDIA may design the most visible part, but the finished processor still depends on foundries, lithography machines, advanced memory, packaging, and testing. Only after all of that does the chip reach the customer. But here's the thing. Once the chip arrives, the bottleneck does not disappear. It moves. It moves into the data center. Now, the operator has a different problem. Can they get enough power? Can they prepare the building? Can they install the rack? Can they remove the heat? A company may own the newest processors in the world, but if its infrastructure takes another 6 months to finish, then a competitor with older hardware inside a ready facility may deliver usable compute first. And that is the real competition. It is not only about owning the fastest chip, it is about turning hardware into a service that customers can actually buy. Some future AI winners will build better models. Others will design faster processors. But many of the quieter winners will solve the problems that get less attention. They will deliver electricity to the building, carry heat away from the rack, and keep the equipment online during every hour of customer demand. Artificial intelligence is marketed as intelligence, but it is delivered through infrastructure. And infrastructure only produces revenue when it works. In the AI economy, every time the bottleneck moves, the money moves with it. This is factory logic.